In level 2, we will be looking at the vertex form of a quadratic equation, and we will be using that form to find the x-intercepts, y-intercept, vertex, axis of symmetry, and then we will also look at where the function is increasing and decreasing. So the way it works, the first thing we're going to look at is determine whether the parabola is right side up or upside down. And we look at the a value. If a is positive, then the parabola opens right side up. And a parabola that opens right side up is like a right side up U, and the vertex is the lowest point, and that would be a minimum point. And if that a value, or the number in front of the parentheses, is negative, then the parabola is upside down. It opens down. And the vertex is going to be a max. An upside down parabola looks like this, and its vertex is the highest point, which is a max. And then the other part of this function that we're going to look at is the h value and the k value. Those two numbers give us the vertex of the quadratic function. The vertex is h comma k, so that is the vertex. But one tricky thing is if you look at this formula, there's a minus in front of that h, meaning when we find the vertex coordinates, we're going to take the opposite of the number inside parentheses so that to counteract that negative, but then for the k, we don't take the opposite. So looking at this first example, I'm going to go ahead and do the vertex first. The vertex of this quadratic formula in vertex form, we look at the two numbers inside the parentheses and at the end. That first number, since it's a -3, I change it to its opposite, and the x-coordinate of the vertex is going to be +3. And then the y-coordinate of the vertex is +8. So I had to take the opposite of the number inside parentheses by the x, but I did not take the opposite of the outer number. And that gives me the coordinates of the vertex. Now, is this a max or a min? To tell if it's a max or a min, we look at the number in the very front. And if that number is positive, the parabola opens right side up. If that number is negative, it's upside down. And in this case, that a value is -2, so it's less than 0, meaning the parabola is upside down. And an upside down parabola has a max. The next part is the x-intercepts. To find x-intercepts always occur when y is equal to 0. So we plug in 0 for y. Now, this function says f of x equals, but that's the same as y equals -2x times the quantity x minus 3 squared plus 8. So we're going to replace the y with 0. So we are basically setting this equation equal to 0. So we get 0 equals -2 times parenthesis x minus 3 squared plus 8. And we're going to solve for x. So we're solving this quadratic equation for x. So I'm going to subtract 8 from both sides. We get -8 equals -2 times the quantity x minus 3 squared. I'm trying to get the part being squared by itself, so I'm isolating that. Now to do that, I'm going to divide both sides by -2 to get rid of that -2, and we get 4 equals quantity x minus 3 squared. And now that we have that part by itself, to get rid of the square, we square root both sides. But when we square root both sides, we have to put a plus or minus out in front of the side with the number. So now when we square root that, we get plus or minus 2, the square root of 4 is 2, is equal to, the square root cancels the square, so we just get x minus 3. And now we have to split this into two equations. I'm running out of room, so I'm going to go up here. One is +2 equals x minus 3. The other is -2 equals x minus 3. And if we add 3 to both sides in each one, we get x equals 5 and x equals 1. So writing these as ordered pairs, that's going to be 5, 0, and 1, 0. Those are the x-intercepts. And for the y-intercept, we are going to we're going to plug in 0 for x. So y-intercepts are when x equals 0, x-intercepts are when y equals 0. So taking my function and plugging in 0 for x, I'm going to put a 0 right here for the x. We get -2 times 0 minus 3 squared plus 8. And then I just evaluate. So this is -2 times -3 squared plus 8. -3 squared, following order of operations, I'm going to do my exponent now. -3 squared is 9. -2 times 9 plus 8, that gives me -18, plus 8, which is -10. So the y-intercept is 0, -10, written as an ordered pair. And the axis of symmetry is the next thing. The axis of symmetry is the vertical line going through the vertex. It always matches the x-coordinate of the vertex, and it's the equation of a vertical line, so it's going to be x equals whatever the x-coordinate of the vertex is. X equals 3 in this case. And before we answer where it's increasing and decreasing, let's draw the parabola. So I'm going to draw the vertex first. It's at 3, 8, so I go right 3 and up 8, and plot a point. I'm going to draw my x-intercepts next, 1, 0, and 5, 0. And they should be on either side of the vertex. The axis of symmetry is the vertical line going through the vertex, so let's draw that. And the x-intercepts should be symmetrical about that axis of symmetry. If they're not, something's wrong. The y-intercept is 0, -10, so we're going to plot that. And using the symmetry of the graph, since 0, -10 is 3 units away from the axis of symmetry, I can go 3 units the other direction and plot another point, which just makes my graph look nice and symmetrical. And then I draw the parabola going through those points. And it's rounded at the top, not pointed. And now the intervals where this graph is increasing, it's increasing on the left side, so that's going to be from -infinity to the x-coordinate of the vertex is the highest point when it stops increasing. And that x-coordinate is 3. And then it's decreasing on the right side from that x-coordinate of 3 to +infinity, because it goes to the right forever. So even though the parabola is going down, that's the y values, but the x values are getting bigger and bigger forever to the right.